Hello everyone. Well, it's very exciting. The reason I'm talking to you today is that as Miss Clark's going to be going off to have her baby in September, I will be taking over as your maths teacher. So lucky me and lucky you. What I'm going to do over the next 2 days is a couple of videos on YouTube for you to watch and to going through some questions that will be really quite similar to what you're going to be facing in your September mock as such. We say mock, but we're just going to be looking at the topics that you've been covering with Mrs. Clark since lockdown began. And I'm going to give you a run through the questions that will really be quite similar to what's going on. Not exactly the same at all, but in the right area. And I will also post online some more questions and worked answers to those as well for you to have a go at, so that you can be thoroughly prepared come September. So therefore hopefully not as anxious as you might be otherwise. Okay, here's the first question, so write it down, have a go at it, or if you like, I have put these questions online. If you've got a printer handy and you could print it off, then by all means you can write on that as well. Okay, so whilst you're doing that, I've been tucking into a hobnob. What I like about being able to do maths at home is have as many biscuits as I like. Doesn't bother me. Right, so a sprinter. So when we're talking about speed, you should know this from science as well. Speed is going to be how far you've gone, the distance divided by the time that you go. And in fact, there's a clue that it's distance divided by time in the units they put here, meters divided by seconds. So all we're having to do here is 200 divided by 25, which is 8. So that just gives us 8 meters per second. Now I'm going to go one little bit further here, because you may be asked to give the speed in meters, in kilometers per hour, or even estimate it as miles per hour. So how would you do that? So in kilometers per hour, there are two things to sort out: the distance, which is different, and the time being different as well. So I would start with the probably start with the time and think, right, how many meters would I go in an hour? Well, from seconds to hours a little bit confusing, so go from seconds to minutes first. So 8 times 60 would be 480 meters in a minute. So then you would have to times that again by another 60 to go from minutes to an hour. So if you times that by 60 again, that would give you 28,800 meters per hour. And then a kilometer is 1,000 meters. So if you then divide that by 1,000, you would get 28.8 kilometers per hour, and that would be that. But they only wanted meters per second. It's only a 1 mark question, but if it was going to be a 3 mark question or something, that would be what would happen. Okay, have a look at the second question, and again pause the video, have a little go at what you think, and then go from there. So this is a compound measure, like speed's another compound measure. So density, and often people forget this one more than others, but again I would say they nearly always give you the unit they want in terms of for density on there, and they've said grams on the top there divided by centimeters cubed. Well, gram, so we're looking at density, and grams are a measure of weight or mass. So it's how heavy something is divided by the volume that goes on there. So you can get your formula just by looking at the question. So we want to know the volume, and we know that the density is 3.5 3.5, we know that just check it, that's in grams, so that's okay, we don't need to change anything. And our mass is 56, and we want the volume, so we just need to rearrange that. Some of you may think already know, yes, I can just swap those two over, or you can do it in two goes. You can multiply both sides by v to give yourself 3.5v equals 56, and then you can divide both sides by 3.5 to say the volume is going to be 56 over 3.5. Now you will have a calculator, or will be allowed when we do this, so we can just pop that in. 56 divided by 3.5, which is exactly 16, so it'll be 16 centimeters cubed. Okay, question 3 then. Once again, pause the video, have a little go. Very nicely, they've actually told you what the formula is here. Now that may happen in an exam, it may not always, but even if not, you can see it here. Newtons is force divided by meters squared is area, and they've said pressure there, so it's actually told to you twice anyway. So we need to know the area, and we know that the pressure is 30. We know that the force is 84, and we want to know the area, which is there. So we can multiply by A to give us 30A equals 84, and then just like we were doing before, we're dividing by 30 to give us A is 84 over 30, which is 2.8 square meters, and the units are on the line, so you just need to put it on the line, and there's no marks for units there, but always look out for that just in case. Now here's a nice question. This has got a bit more to it, hasn't it? Right, Dylan, Eli and Fabian share some sweets. Dylan gets to the amount of sweets the number of that Dylan gets to the number Eli gets are in 7 to 3. So that's Dylan to Eli is 7 to 3. The amount Dylan gets to Fabian is 4 to 5. Now sometimes you can simplify everything all together. If you wanted to, you could multiply these by 7 to get 28 to 35, these by 4 to get 28 to 12, and then you've got them all together, but you don't actually have to do that. The bit I'm going to look at first of all is this bit of information here, just between Dylan and Fabian. So I'm going to draw a bar. If you get confused at all, draw a bar and think about it. So you've got 4 parts to 5. So Dylan's got 4 parts, Fabian's got 5 parts, and he's also got 21 sweets more. Well, this bit here is more than Dylan, so that means that those 21 must be in there. Now the whole point of ratio is every part has to be equal. So if you've got 21 there, you've also got 21 there, 21 there, and so on. You've got 21 in each of those. To work out how many sweets Dylan has got, we just need to add all those up. We'll do 21 times 4, which is 84 sweets, and we need to know how many Eli gets. Well, now we can just say Dylan to Eli, 7 to 3. So what's 7 to 3 look like? 7 boxes, 1, 2, 3, 4, 5, 6, 7, and we know that Dylan has got 84 sweets, and Eli is going to have 3 boxes the same size over there. So to work out how much in that box, well, you've got 7 boxes and all of them have to be the same, so you divide by the number of boxes, and you'd have 12 in each box all the way along, which means Eli also has 12 in each box, and that's what we want. So 3 times 12 gives you 36 sweets. Lots of other ways you can go to work these out, but I think if you get confused at all, draw a bar and see if you can make sense of it for yourself. That's the key. Right, direct proportion question next. Now I like to encourage people whenever they try to do direct proportion to sort it out as a formula first. They're not asking for a formula on this one, but it's the best way to make sure you get it right. And very often they ask you to put write down what a formula for A in terms of B anyway. So we'll start with that. Directly proportional means A. I've never quite been sure what this symbol here is called, but that means directly proportional to, or you can just call it fishy thing. So A fishy thing B, and what that means is that there will be a number that you can multiply B by to make A, because when things are directly proportional they get bigger at the same rate. So we've got A, we've got KB there, and all we do now is put the values that we've got here into our little formula and find out what K is. That will give us the number, the multiplier that links them. So we can say that would be 28 times K. So K, solve that by dividing by 28, will be 7 over 28 is K. Well, 7 over 28, that will simplify to a quarter. You can put that in your scientific calculator and it'll do that. So that means that A is equal to a quarter of B, or B divided by 4, depending on how you want to say it. Now we want to know what B is when A equals 5. So we're going to substitute 5 into there. So 5 is equal to B divided by 4, or a quarter of B. So to solve that, we just multiply by 4, and 20 must be B when A is 5. And that's direct proportion sorted. Moving on now to similar shapes. Just a couple of questions to go, to be honest. We've got, first of all, similar lengths. It says diagram not accurately drawn because they don't want you to be able to measure them and work it out that way, so you won't get anywhere that way. So it's all about looking at E to D is this length here, and we know that length there. So we've got two similar triangles here, because if all the angles of a triangle are the same, then the triangles will be similar, which means that you can multiply each length by the same number to get the larger one. So we're going from 9 up to an overall length here, but this length is going from 9 to 9 plus 3 is 12. So 9 times whatever it is that we're linking it with, so let's call that, or I could call it anything, scale factor, whatever, 9 times f a factor, 9 times our scale factor is giving us 12. So that number that we're multiplying 9 by is going to be a little bit more than 1, isn't it? It's going to be 12 over 9. And what's 12 over 9? We'll divide top of, that's 4/3, isn't it? So that means if I multiply 6 times 4/3, that's going to get me the whole length, which is 24 over 3, which is 8 centimeters. So if 8 centimeters is that whole length, E to D must be 8 take 6 is 2 centimeters. Oh, I've just realised that I probably worked that out a slightly more complicated way. You may have spotted something else. You may have spotted that this distance here, the extra bit, is 1/3 of that distance there. And actually, the 2 centimeters is 1/3 of that. So if you can spot another way in which you can see the multiplier, then by all means go for it. And the second part here is to work out the length of BE. Well, if we're multiplying by 4/3 to go from the smaller triangle to the bigger triangle, here we're going from the bigger triangle to the smaller one. So we're going to do the opposite. So instead of multiplying by 4/3, I'm going to divide by 4/3. So 7 divided by 4/3. Well, when we divide by a fraction, it change to times and then flip to 3/4 like that. 7 times 3 is 21 over 4. 21 divided by 4 is 5.25 centimeters, or 5 1/4. Right, here's our last example for today, which is about mathematically similar 3D shapes. And what you've got to remember there is that your scale factor will link how many times bigger the lengths are, and you need to remember that, I'm going to make a little table here, for lengths it will be multiplied by what we call the scale factor, which is how many times bigger the lengths are, like in the previous question. For area, because you've got 2 dimensions, it will get that many times bigger both ways, which means you've got the scale factor times the scale factor. So that's the scale factor squared, and the volume will be multiplied by the scale factor cubed. So if you're going from length to volume, you're timesing by the scale factor cubed, and if you're going the other way, you'll be dividing by that scale factor cubed. So we need to be thinking about that. Now they've told us our information here as being the surface area, and what we need to look at is how many times bigger. We want to know the length of cylinder Q. So we know it's longer, but how many times longer will it be? From 90 up to 90 times pi, 810 times pi. Well, the pi doesn't make any difference, it's just that many times bigger. We don't need to worry about the exact value. 810 divided by 90 is 9, isn't it? So that is 9 times bigger, but that means that the scale factor squared equals 9. So if the scale factor squared is 9, the scale factor will be the square root of 9, which will be 3. So that means that all the lengths, the radius and the diameter and the height of this cylinder, will all be 3 times what that length is there. So because of that, I can say 4 centimeters times 3 is going to give me 12 centimeters. Now the next part of this is to say, right, you're told that the volume of P, now P was the smaller one, is 100 pi centimeters cubed. And giving your answer as a multiple of pi, work out the volume of cylinder Q. Well, it's going to be the volume multiplied by the scale factor cubed. And we know that the scale factor is 3, so it's going to be 100 pi multiplied by 3 cubed, which is the same thing as saying 100 pi multiplied by 27, and 27 times 100 is 2,700. The numbers on these things are always reasonably simple, because they know that so many people are going to get confused by it. So I'd always say, whenever you start off with that idea of saying, right, length is scale factor, area is scale factor squared, volume is scale factor cubed. Okay folks, well I hope you've enjoyed that a little bit, and I'll see you tomorrow for some trigonometry. Okay, cheerio.